Well, great. Hello again. I am Semyon. I'm from St. Petersburg State University, and I want to discuss the current state of context-free path querying. Context-free path querying is a partial case of formal language constraint path querying, and formal language constraint path querying is a framework for navigational queries in H-labeled graph. Suppose we have this graph, and one want to find all vertices reachable from 0 by the following path. The path should start from two edges. The first one is A and the second one is B, and the rest of the path is a sequence of edges C and D in arbitrary order. There are several paths in this graph. For example, this one from 0 to 3 and this one from 0 to 5. Formally, formal constraint path querying with reachability semantics is the following problem. For the given graph and the given language, we want to find all pairs of vertices such there exists a path between them, which forms a word in the given language. The language can be regular, the language can be context-free, even more it can be in a more expressive class, for example, in multiple context-free languages. Note that we can vary not only language classes, but also other parts of problem statement, but these parts are typical for other graph analysis related problems. So where we can use context-free path querying? Basically, context-free path querying can be used for hierarchy analysis, and it's important because this type of analysis cannot be expressed in terms of regular languages, but can be expressed in terms of context-free languages. Since context-free path querying was introduced by Yanakakis, it was shown that context-free constraints can be used in such graph structure data analysis as biological data analysis, data provenance analysis, and so on. And at the same time, it was shown that context-free path querying can be used for static code analysis. So nowadays we can think that graph analysis systems or even graph databases can be a common base for context-free path querying related tasks in a wide range of areas. But there are some obstacles to use context-free path querying in real-world applications. And the first one is about algorithm choosing. So how can I choose an appropriate algorithm for my particular problem? There is a number of other questions which require to compare algorithms to be answered. And yes, of course, there is a well-established classical solution for this problem. It's unified benchmarks, but to my knowledge, there is only one attempt to compare different context-free path querying algorithms with slightly pessimistic conclusion. So to improve the situation, we should collect unified benchmarks, unify benchmarking process, and we should keep in mind that, first of all, we should collect data from a wide range of projects, papers in different areas. And the second, we should carefully analyze different use cases, different scenarios to select a representative benchmark process. And the second one is a small number of ready-to-use systems which supports context-free path querying. So even one can reduce the problem to context-free path querying. It is not easy to evaluate the solution. This problem is more complicated because first we should do is to select an appropriate algorithm. So we need to establish a benchmarking process and so on. Moreover, we should to provide graph querying language which supports features which allow one to express context-free constraints. And I guess that graph query language standardization can help to solve this problem. Our team also works on these problems, and first we developed and published a collection of linear algebra-based context-free path querying algorithms. Second, we provide full-stack support of context-free path querying in Redis graph. So now one can try to use context-free constraints in more or less user-friendly environment. Also, we are working on dataset for context-free path querying benchmarking. Our dataset contains both synthetic and real-world graphs, but work in progress. We should collect more graphs from different areas. We should unify queries format and so on, but preliminary results are published, so it can be used in other research. Here you can see a more practical point of view on our results. It's benchmarking on biological data and static code analysis related data. First, we can see that context-free path querying algorithm performance is significantly improved in the last few years. But of course, careful detailed analysis of different algorithms in different scenarios should be done in the nearest future, I hope. For example, we are working on detailed evaluation of our Redis graph-based solution. Also, we are working on benchmarking of other linear algebra-based algorithms. We are working on CFPQ algorithm for Neo4j. We hope that we can provide appropriate solution for some practical cases. And also, we are thinking about graph querying language semantics and its formalization. And we are thinking about utilization of more expressive than context-free languages classes for path constraints. Finally, I think that context-free path querying should be a part of graph analysis ecosystems. Moreover, I think that formal language constraint path querying should be a part of graph analysis ecosystem, not only for regular languages or context-free, but it requires a significant effort from community. First of all, we should publish benchmarks. Second, we should organize competition on formal language constraint path problems. And I think that it's important to involve static code analysis community to share knowledge between different communities, to share techniques, algorithms, and so on. And finally, I hope that we can provide graph database support for formal language constraint path querying, but this problem is very complicated, and I think that it's field for discussion, but I think that it's possible. Thank you for attention. That's all, and I'm ready to answer your questions.
Thanks, Grigorev. Semyon, sorry. Are there questions from the audience on this talk, on the formal language constraint path querying? So I have a question. So you say, okay, you make a plea to create new benchmarks for this. But I mean, at least from the data part I would hope that the data generators and the data sets that we have in current graph benchmarks would be suitable for testing these or not?
Interesting question, not? Because the main difference between existing benchmarks and benchmarks that we need for formal language constraint path querying is that we need H-labeled graphs, but not all existing generators can provide H-labels. And moreover, graph queries is hardly related with one particular graph, which can provide additional problems. But I hope that some of generators can be used, not fully, maybe they should be tuned, but it will be nice to reuse existing stuff because it's hard to create a new one from scratch. But it's a very complicated problem, so we should first analyze existing solutions.
Okay. Okay, thanks for that answer. I think, well, people who come up with questions later on, please do not hesitate to contact Semyon. And but now it's time to go to the last talk in the session.